This video is over topic 43, multi-step experiments. So, uh, multi-step experiments, so you have one experiment repeated, or you have two different experiments and you're looking at the combined results. So the sample space is all the possible combinations of those steps. So if you flip a coin and you roll a four-sided die, you could have 1, 2, 3, or 4 on the die, heads or tails on the coin, and then all the possible combinations. Here I made a table. Um, and with this, heads on the coin and 1 on the die could be represented as H1 or 1H. It doesn't matter. If I'm doing one thing repeated, then order does matter. So if I'm flipping two coins, each coin could be heads or tails. My combinations could be two heads, could be tails, could be one of each, but the one of each has two ways to get that. So if you think of those as two different coins, say a quarter and a nickel, heads on the quarter, tails on the nickel is different from tails on the quarter, heads on the nickel. So what we do is we impose an order onto this. So even if they're two quarters, they're still two distinct physical objects, but it's easier to distinguish by just a first, second versus like the two objects. So we'll write TH versus HT as two different outcomes. These can also be represented by tree diagrams, so you can look at these tree diagrams for both of those scenarios. All right, practice number 1, we have 4 cards numbered 1 through 4 and 3 balls labeled A, B, and C. We're picking a card and a ball and looking for the possible combinations. So listing out the sample space, you just want to be somewhat systematic with that. Maybe do all the ones. So 1 could be combined with A, or with B, or with C. And then 2 could be combined with A, or with B, or with C. 3 with A, with B, or with C. And 4 with A, or with B, or with C. We could also write this as like do all the A's first. So 1A, 2A, 3A, 4A, and then 1B, 1A, 1B, 1C, 1. Sorry, what am I doing here? 1A, 2A, 3A, 4A, 1B, 2B, 3B, 4B, and then 1C, 2C, 3C, 4C. And these could also be written like it could be instead of A3 could be or sorry, instead of 3A could be A3, either way. We could do this in a tree diagram 2 different ways. So we could start with the cards. And then each card could be combined with any of the 3 balls. So we split each branch. Or we could go the other way and start with the 3 balls. And then split each of those again, now into 4. Whether we're listing it out, doing the tree diagram, there are 12 different combinations of these. With the tree diagram, you can count the smallest branches. But you can also think, well, there's 4, and then each of those get split into 3. So there's 4 groups of 3, or on the other one, there's 3 groups of 4. That's multiplication. 3 times 4, or 4 times 3 gets 12. All right. The event that ball B is chosen would be And the first tree diagram here would be the middle sort of twig on each branch versus in the second one, it's just that whole B branch. But it's going to be, say, 1B, 2B, 3B, 4B. And then how many outcomes involve an even number? Well, that would be all of the ones with a 2 or a 4, which is half of them every other, or depending how you're grouping it, a total of 6. All right. Then the next, number 2, a tree diagram for the possible sexes of 3 children in a family with G for girl, B for boy. So here we do have to just stick with an order. So we have first child could be girl or boy. Then with each of those results, second child could be girl or boy. And then each of those previous pairings could have a third child, girl or boy. Okay, so that comes out 8 in that final branch. How did that 8 come from? There were 2, and split into 2 groups of 2. And then each of those split into groups of 2, so now 4 groups of 2. What's happening? Those are getting multiplied together. 2 times 2 times 2, or 2 to the third power equals 8. So when you're repeating an experiment that has a sample space or a sample size of whatever, so let's get this repeat experiment with sample size n and repeat it k times, then it's going to be n to the k combinations.